Hi there, I'm going to show you how to do the sampling distribution. In inferential statistics, what a sampling distribution is it's the distribution of a sample statistics calculated on all possible samples of a given size that's drawn from a well-defined population. So let me start off with that definition by putting together a well-defined population. Okay, so let's say that this is my frequency here. And let's say I have three values in my population. So basically what that would look like is okay, so this is my population. And this is my population set. Okay, so I could have, for instance, one each of my variables, which would be one of one, two of two, one of two, and one of three. Okay, so these are my variables here. So basically what I'd like to do now is take a sample set from this well-defined population, and I'd like to make a sampling distribution of it. So I want to do the same distribution like this, but only of a sampling of these variables. So I'll take all possible combinations of these variables, and then I will draw another distribution and lay them out and show you what is going to be done there. So in order to do all possibilities, what I'm going to do is basically first I have to just decide how many combinations I want. So let's say I want 2 because I don't want to make it too complicated right now for this example. So I will just write, I will make one, pick one, and all right, I don't have a tripod, so it's a bit wonky to do this, but I'm going to do this anyway. Okay, so basically what I'm going to do now is make all possible combinations of 1, all possible combinations of 2, and all possible combinations of 3. Okay, and this is what that looks like. So if I have 1, 1, and 1, and if I do 1, 2, and 3, it basically means 1 can be matched with 1, 1 can be matched with 2, and 1 can be matched with 3. There are no other values in this set, so there's no other combinations for 1. So we do the same thing for 2 and 3, and then we would have combined all of them in every which way that they could be matched. Okay, so just to keep them separate, I'm just going to draw a quick line here. Again, do the same thing for 2, combine it for 1, 2, and 3. Those are the variables. And combine variable number 3 with all possibilities of that combine with 3, which is 1, 2, and 3. So now you can see we have made 2 choices to match with all the variables. And what we have now is 3 here, 3 here, 3 possibilities here, which obviously equal to 9. So this is the total. 9 is the total possible combinations or possible samples, all possible samples equals 9. Okay, and now what we want to do is we want to calculate what the statistics on here, just as we would have a sample, but this is a sampling, so we want to calculate the mean and the variance and the standard deviation on all of these values. So I'm just going to put an equal sign here, equals, so each of these combinations is going to have a mean, an average, and just to let you know that on a combination of n equals 2, which is, this is basically 1 and 2. On combinations of 2, the mean that's going to be calculated and the median are going to be the same, only the symbol for the mean is different than median. Median has a little squiggly over it instead of a straight line, so it'll go like that. But we're doing mean, so we're just going to do a symbol for mean, which is covered in descriptive statistics, which I'm not covering here. So if you need any help with descriptive statistics and to figure out what I'm doing here, just watch a video on descriptive statistics. Okay. Now, for the mean, you just add the 2 and divide by the total number, so you're going to get 1. And then for this one, you do the same thing. So you're going to get 1.5, and then you're going to get 2. And here, you're going to start off actually with 1.5. 2 plus 1 is 3 divided by the total number, which is 2. And then this one, which is going to be 2, and 2.5, which is 5 divided by 2. And now you can see that they're going up by half a point. So guess what this one's going to be? It's going to start off at, this one started off at 1.5, it's going to start off at 2, 2.5, and 3. 3 plus 3 is 6 divided by 2 is 3. Okay, so now what we're going to do is we're just going to look at all of these combinations and see how many of each there are. So we can see that there's just 1, 1, right? So we'll just write down 1. Let's write it down with this so it's nice and obvious. There's only 1, 1 in all of these. How many 1.5s are there? There's 2, so I'm just going to write 2. How many 2s are there? There's 3, so there's 3 2s. We've already done 1.5, we've already done 2.5, there's 2 2.5s, and we've already done the rest, and 3, there's just the 1 3. So I just do this to keep track of what's going on so that when I'm actually doing my distribution table, first, it works really well for a small number, so I've already done some of the work ahead of time. So now I'm going to put this onto a distribution and draw another distribution table for you. Okay, label properly. So this x here is actually going to equal the x bar because it's a sampling distribution. And this is going to be probability function. Okay. Now, what I'm going to do from here is put in all the details that are here. Sorry, from here. These all go into my distribution. So I just start off at 0, and I go to 1, 1.5, 2, 2.5, and 3. Okay? 1, 2, 3, 4, 5 possible means that I have here. Okay? This is the mean. Okay, so now on this side I'm just going to label the first I'm just going to label the frequency, and I'll show you what's going to happen here. So I'm going to label the frequency. What did I do? Sorry. I have 3 on my mind. Okay, and so you just go in and put the numbers that were up here, all of these corresponding to the numbers. So I can see them, you can't see them because like I said, I don't have a tripod, so I can't show you. But basically all you have to do here is you just say, how many 1s do I have? Well, I just had 1, 1. How many 1.5s? Well, I had 2. Sorry, this is kind of wonky. And I had 3 2s, so I just do 3 2s corresponding to 3. And I had 2 2.5s, and I had just 1 3. So as you can see here, this is actually, the shape of this is supposed to go like that. It's supposed to be like that. Okay, so now basically I just want to get the mean of the mean. So basically this is my center point here. And how do I know that? Well, what I'm going to do is show you how I got that. Basically, I just add up all my numbers, all my means. 1 plus 1.5 plus 2 plus 1.5 plus 2 plus 2.5 plus 2 plus 2.5 plus 3 equals 18 divided by the total number, which is 9, divided by 9, and that equals 2. Okay, so that is my sample mean of means. Okay, that's my mean of all of the means. Okay, oops, sorry about that. Okay, so that's how I got that this mean is equal to 2. Okay, right here. All right, so now what I want to do from here also is to do my standard deviation, and I believe that's just marked with an S. Okay, so how I get the standard deviation is I basically count all the distances from the mean of all these variables, of these values, and then I square them. And then I get the average of those, and then I get the square root. So first, before I can get the standard deviation, I need to get something that's called a variance. Okay? So basically, take all these values. What is the distance of 1? 1 from 1 is only 1. What's the distance of 1.5 from 2? It's just, and this is the absolute difference in the distances. As you can see, I'm like minusing them, but it's negative, but then you just do absolute average distance. Average. okay, is obviously 0.5. And then 2 minus 2, 0. And then distance from 2.5 to 2, well, it's -5, but we're doing absolute average distance, so, well, we're actually not going to do the average, but we're just going to calculate here. So, well, I'll show you what I'm going to do. And then finally, 3 minus 2, so that's only a distance of 1 point. Okay, so now that I have all those, I just want to, in order to get my variance, I just square all of them, okay? And then what I get from all the squares, 1 squared is 1, 0.5 squared, I'm never good at decimals, so I always double check to make sure, but it's I think it's 0.25, yeah, it's 0.025, and then that's just 0, 25 again, 1 again. Okay, so now I'm going to just add all of that. So I always use calculator because I just want to make sure that I've got the right calculations, because sometimes you get a little confident in your mind, oh, this is easy, and then you just make some small silly error. So I just use a calculator quickly. So that's 2.5. Okay, so all of that added is 2.5, and then when I get the variance, so to get the variance, I take that 2.5 and I divide it by the number here, which is 5, the total number. Okay, and that's 2.5 divided by 5, which equals 0.05. Oops. Sometimes you can have calculation errors, sometimes you just have spelling errors. Okay, so now this is the variance. That is true. That is true. But to get the standard deviation, you would have to do a square root of 0.5. So square root 0.5, and I'm using the s, so I'm just going to do, it's 0.707, so I'm just going to put, well, I'll just do 707, so that the square root equals 7, 1, right? Okay. Okay, this is kind of blurry, I'm not sure what happened there. Okay, sorry if it's not too blurry. I don't know how to correct that right now. Okay, so basically standard deviation is 0.71. Oh, I wish this would just stop. 0.71. Okay. Okay, good. Back in focus. Okay, so now we've got our standard deviation, we've got our mean, and that is your sampling distribution. If we want to go one step further and we want to calculate a probability, let's say a probability of, let me just write down, let's say I want, what is the probability that x would be greater than 2.5? Let's say that's my question. Well, my answer is going to be the following process. So the probability that x is greater than 2.5 is going to be this plus this, right? But what are our odds here? So we have to basically count everything up. 1, 2, 3, 4, 5, 6, 7, 8, 9. So of all the possibilities, there's 9 possibilities. So you just put everything over 9. over 9, like that, right? Because this is a probability function. So when you're trying to answer questions of probability, you change it like this. And then what you do is you just say, well, this is, basically this is a 2 out of 9, right? So the answer is 2 out of 9, 2 out of 9 to get a 2.5, because this line here goes to 2.9, okay? This one goes to 1.9, so you go 2.9 plus 1.9. We already have a common denominator. So we basically just say that it's 3 out of 9. 3 goes into 3 once, 3 goes into 9 3 times. So basically it's a 1 in 3rd chance. Now, you could that could be your answer. That's totally legitimate answer. Or 1 divided by 3, which also equals 0.33, which you could also convert to 33. Well, I mean, if you really wanted to be, you could just say 33.3% or 33%, right? So depending who's asking you, there's 1/3 possibility or 33% possibility, okay? So not only have we done sampling distribution, and hopefully you can see now that this distribution of this is now a sample statistic distribution, and it's been calculated on all the possibilities here. We've done all the possibilities of a given size, so we just wanted to pick 2, right? From a well-defined population. So this was our population that we drew from. So that tells us that our definition really makes sense for sampling distributions. The distribution of a sample statistic calculated on all possible samples of a given size drawn from a well-defined population. There you go. And just did one step further, and we just did a simple probability calculation of chance of probability of x being greater. And we calculated that for you, in case your instructor is wanting that from you as well. And that should be it. Thanks for watching. Bye.